In this video, we're going to go in the opposite direction of what we've done the past two videos. In these videos, we'll have the area underneath the normal distribution. We'll want to find the specific measurements associated with those probabilities, with those areas, with those percentages. And so to do this, we're going to go to the same menu under second and then bars, but we're going to select the third choice, inverse norm, instead of normal CDS. So we're going to go right below that, and we input three items this time. We input the percentile as a decimal, then the mean and the standard deviation, and we hit enter to get our result. So it's best illustrated with a few examples. Let's look at example one and progress through these. The lengths of red drumfish follow an approximate normal distribution. So I've got a normal curve that pretty much signals I'm in chapter 6. The mean is 15.4 and the standard deviation is 4.5. I want to know what minimum length puts red drumfish in the top 10% of length. Just like before, I'll draw in a rough sketch to get an idea of what's going on. My mean here will be 15.4. So I want to know, well, what is this measurement? What is this marker that puts these red drumfish in the top 10%? I'm going to use a little bit of the complement here. If this is 10% of the distribution, that leaves 90% for the left-hand side. This would be known as the 90th percentile. And that's what we're always going to use with this inverse norm function. We're going to use the percentile. We're always going to use the left-hand percentage. Regardless of the percentage given the problem, we're going to use this left-hand percentage. So I need to find what this is. It's the opposite of what we've been doing. I have the percentages. I want to know the marker, so I'll select the inverse norm, number 3. You enter the left-hand percentage as a decimal, so it'll be 0.9, comma, the mean is 15.4, standard deviation would be 4.5. Hit enter, and that tells me this marker must be 21.17 inches. If a red drumfish reaches 21.17 inches or more, it's in the top 10% of these fish in their length. It's in the 90th percentile. Example 2 is similar, so let's look at it. It says the time it took students to complete a test follows a distribution that is approximately normal. The mean was 55 and the standard deviation was 6. How long did it take the fastest 5% to complete that test? The sketch is important. I would encourage you to sketch it out every time. Got my 55 in the middle. Now, the fastest 5% compared to the slowest 95%. Think about where the fastest students would be at on the curve. This is how long it takes a student to complete a test, so 55. The next marker, because the standard deviation is 6, would be 61. To the left, it would be 49. Your fast test takers are on the left-hand side of this curve, right? 49 minutes to take the test is faster than 61 minutes. So I want to see, well, what mark down here separates the fastest 5% from the other 95%. What is this? So I have the percentages. I want to know this. And when you want to know one of these bottom measurements, when you have these percentages, that's when you use inverse norm. So it's second vars. It's the third one. I'll just hit the number 3. And it's the left-hand percentage every time. So up here we used 0.90 for the fish. Here we're going to use 0.05 for that 5%, comma, the mean is 55, comma, the standard deviation that was given is 6. And so that tells me the student finished in 45.13 minutes or less, he or she is in the fastest 5%. We'll do one final example to reinforce this inverse norm. The normal model N279 describes the length of pregnancies in days for women who go into spontaneous labor. So the average number of days is 270, the standard deviation is 9. If 60% of women have a pregnancy below this number of days, what is this number of days? I'm saying this is known as a measurement or an inverse statement that we're trying to find. Just a quick, rough sketch. %60 should be below. Well, if I draw a line at the 270, that's going to split it 50 below and 50 above, just by the symmetric property of the normal distribution. So I need a line just above the 270. So I have 60% below and 40% above. How many days of this is this? I know it's over 270, but exactly how many would it be? So the second vars, inverse norm, 0.60 or 0.6 for our percentile, the left-hand side, 270 for the mean, 9 for the standard deviation, and we get 272.28. 60% of women have pregnancies below 272 days or so.